In this problem, we're going to try to find the distance, the minimum or the minimal distance between two circles. We assume that the circles don't intersect. Okay, so clearly we can use trial and error. We're going to prove this one later using calculus. So given two circles, so let's say this is our circle, the first one having radius R and center A, and this one having radius R prime and center B. The minimum distance between the two is these 2 points that are lying on this line that connect the two centers. Okay, we can analytically find these 2 points. So we have the centers. We know the coordinates of the center of the circle A and the center B. We know its coordinates. So we have 2 points. We can construct this line, and we can for instance, either solve the equation of the intersection between a circle and a line and find this point. The same thing here. So we have the equation of the line and we have the circle. We can find the second point, or we can find the tangent that is tangent to the circle here and this one here, and we can solve for 2 lines. Here we know the slope of this one, and we know the slope of the orthogonal or the perpendicular line, which is -1 over the slope of this line, and we can find and we can solve this equation and find these 2 points. Okay, but in our case we don't want to solve for these 2 points. We can do something else. So here we know the distance. So we call this distance between the centers of the circles. We call it big D. Okay, we know this distance here. So here D is, so this distance here is just the radius. Okay, so this is the radius of the circle A. So big D is the radius of circle A plus the radius of circle B plus the distance that we are looking for. So this is ds. Okay, so therefore we can find ds as d minus ra minus rb. Okay, so we find d by using the distance formula because we know the centers. Okay, we can find these points, the centers of the circles. Okay, for instance, here we have this example. So this is our first circle. It is centered at point 45 and having radius 3, and the second circle is centered at 1, 0 and having radius 2. Okay, so to find the distance between the two centers, which we call d, so here we're going to use the distance formula. So it's going to be 4 minus 1, which is 3 squared, plus 5 minus 0, which is 5 squared. So therefore we have 9 plus 25, which is 34, the square root of 34. So this distance here, the d between, so we know d. Now we know r. R of the first circle, it's 3. The radius of the first circle, it's 3 squared. And this is 2 squared. So therefore the radius of the first circle is 3 and the radius of the second circle is 2. Okay, now using this formula here, we can find the distance between the two circles. So ds is just this distance between the centers minus the first radius minus the second radius. So it's the square root of 24 minus 5. So this is the distance that we are looking for. Okay, note that this distance has to be positive. And of course, because the square root of 34 is more than 5. Okay, so this is a positive value. Okay, so therefore this is the distance, the smallest distance between the two circles. Okay, we can find another proof of this formula by using calculus. Okay, we can find it, but we're gonna come back to it. Okay, so here we can write the equations of the circles in general. So we're gonna write the center as AB and CD, and the radii as R and R prime, and we can find the minimum distance by solving an equation. Okay, but for now we accept that the distance is given by this formula here, and it's clear. Okay, it's clear because once we move outside of this line, let's say it's here. Let's say if we say that the distance is here, we're gonna get something bigger. Okay, using the properties of the triangles. Okay, so the minimum distance, if we are given the circles, we can use this formula here to compute it. Okay, so that's the solution. So the smallest distance is this one, the distance which of these 2 points that lie on the line. We can find them, or we can just use the distance formula and get all we need clearly. Thank you very much.